another super small chapter. Like I said, hey, after fractions, everything gets much smaller. And hopefully, for the most part, people do quite well in this one as well. Right? This one's only 3 lessons long. I usually like to get this chapter done before spring break. I don't think that's going to happen this year. I would like to have it happen this year. I don't think we'll quite get there. All right, we have 4 classes left, including today, before spring break.
That's it?
I think so. Wait, no, maybe 5. 5 including today. All right, so with 3 lessons in there, plus the assignments and quizzes, we might get there. I don't know. Which makes it kind of difficult because we're going to have to try ready to test 1 or 2 classes after spring break. It is what it is. Okay, so this chapter is called Ratios and Rates. Day 1 and day 2 are the ones with the most content, and day 3 sort of connects a couple of ideas together, right? So start off with your name. We're at block 4 of day 2, so 2-4. All right. Okay. So now, let's get started here. Ratios, right? So ratios are used all over the place. They're used to compare 2 things that have the same units. Okay? So the measurements are not. Yeah, go ahead. Okay. So now, I can give you an example. For example, you have a business and you make fruit baskets, right? And you have a recipe for making your fruit baskets, right? So, for example, this is your recipe for your fruit baskets. For every 2 apples you put in, so maybe 2 apples you put in, you are going to also put in 7 pears. Okay? That's your recipe. So say that's your small fruit basket, and you want to make a larger fruit basket, and you put 4 apples in it. How many pears would you put in?
Wait, what is it?
So your recipe is for every 2 apples, you put in 7 pears, right? Right? What if you wanted to put in, say, a larger fruit basket, and you say you have 4 apples? How many pears would you put in?
14. Yeah.
14. The relationship keeps the same. So this is describing a relationship. These 2 little dots here, these colons, this is your ratio, describing how these things are connected, right? And we are not limited to only talking about 2 things. Ratio, right? So now, for the most part, in grade 8, we'll talk about 2 things, or usually 3 things max, but you can make these things go as long as you want. For example, if you want to do 3 terms ratio, we're comparing 3 things, all with the same units. So for example, if you have your fruit basket and you have your 2 apples, and you have your 7 pears, and let's say you put in 3 bananas as well. All right? So you connect multiple things together, right? So we do the same thing, right? If we say we put in 4 apples, and we said, okay, last time that's 14 pears, how many bananas would be in the medium size? 6. We don't. So just connecting all these things together, right? So very useful, right? So ratios come in use lots in our lives. Lots of times they give instructions inside of bottles, and instructions for generic amount. Like for example, the last time I gave you one of the extending questions was my pool stock. If you remember that extending one. So everybody has different size pools. So they give you instructions for a generic size, say 1,000 liters, and you kind of multiply to whatever size you have, right? So my pool was, I think, 16,000 liters. So the instructions you just multiply appropriately. So a lot of instructions are given this way. Now, there's 4 different ways we can express ratios. And we're going to talk about this using the following scenario. All right, we're going to talk about athletes. We have 23 athletes. Of them, 14 play hockey, and 9 of them play soccer. Okay? So we want to write different ratios down. So one thing we could say is that for every 14 hockey players, we have 9 soccer players. That's one ratio we could say for the relationship. Sorry?
You have to write what they are.
No, I'll get to that later on. All right. Or we can say comparing hockey to soccer, we can say there are, for every 14 players there are 23 athletes. We can compare those things together. Or we could say for every 9 soccer there's 23. So the same scenario can have multiple different ratios, right? Describing. So that's using ratio notation with 2 colons and stuff like that. We can also describe relationships using fractions, percents, and words. Okay? Now, if I take these ratios and I'm going to write them as a fraction, I just go first one over second one. First one over second one, first one over second one, first one over second one. That converts right from a ratio to a fraction, first over second. Now, 2 out of these 3 things that I wrote down are correct. One of them doesn't work. Do you know which one doesn't work?
14 over 9.
Why doesn't 14 over 9 work?
Because the denominator
Right.
needs to be bigger. No.
That is an issue, but the other issue is when we're trying to find fractions, compare things, we want it out of a total, right? So this is not a total. 23 total athletes. So this one, you got to be careful. It doesn't. You can't write the fraction. So fractions, the bottom number, right? The denominator must be total. Okay, so this one doesn't work because the bottom isn't the total. All right? Does that make sense? Right? Fractions are always out of totals. Now, the next version of talking about comparing things is by using percents. And we just did a whole chapter on it. And we did fabulous. All right? And so we
How about you?
convert our fraction into our percentage. So like here, we can't use this one because we need a total, right? So we get our fraction, right? And let's see if we remember our steps from before the weekend. So we have 14 over 23, right? How do we turn that to a percentage? 14 divided by 23, we turn that into a decimal, so grab our calculator. You go, okay, start that up. I go 14 divided by 23, I get 0.6086, keeps on going. Say if I wanted to write it to 2 decimal places, what number would I write down? 61, the 8 tells us to round this up. So this equals 0.61, so what percentage is that? 61. Remember, times by 100 or move the decimal 2 spots. It means the same thing. So this is what we can say 61% are hockey players, right? 61% are hockey players. Right? And we can do the same thing for the other one. We can go find the percentage of players that are soccer. So we have our total 23, 9 out of the 23 players are soccer. And this is sort of how we did the granola bar question. A lot of people had trouble with that one, right? How much fat? What percentage fat? Oh, he had 9 grams of fat. Out of the total grams of fat he had that day, 40. 9 out of 40. You figure out that as a percentage, right? So you turn this into a decimal. By the way, before even using your calculator, can you tell me what the answer for this one should be? Can you do it without a calculator? right? You can use our previous answer as the clue. If 61% of the players are hockey, how many must be soccer? 39, because it adds up to 100. The rest must be hockey. Now, if you did this calculation, right, it should give us 39. Let's just hope it does. 9 divided by 23 is 39, 0.39. Right, so that means 39% are soccer. Okay. So all these percentages should add up to 100. And the final way we can describe this is just like using our word or sentences. Describe the relationships. This one takes the most amount of effort, right? So something along the lines, there are 14 hockey players for every 9 soccer players. Right? So by this statement, suppose that's this school. What's the more popular sport? Hockey, according to this, right? All right. So now, there are 2 different kinds of ratios. I'm going to talk about it using the different scenario. And I made some typos here, so we're going to fix it as we go along. All right. So for the following scenario, we're going to write it in ratio notation, we're going to write it in fraction, and we're going to write it as a percent. All right. So suppose in our class, 7 out of 30 students went to Albert McMahon Elementary School. All right. That's our relationship there. Right? Jake, you taking some notes here, bud? All right. So we want to write this in ratio, fraction, percent, and words. Right? As a ratio, what would it be? 7 and 30. Just like that. Right? As a fraction, what would that be? Yep, that's right. 7 over 30, like that. And finally, as a decimal, right? Go 7 divided by 30 in your calculator. What do you get? 0.23. So you turn that into a percentage, 23%. Right? So now the hard one is just kind of write it in words. Now there's more than one acceptable answer, as long as you describe the relationship. So what's coming to my mind right now, I can say, for every 30 kids, 7 attended Albert McMahon. How do you spell McMahon now? Man. All right.
But when we answer questions in the assignment, it'll just be one answer. Like, or we have to write all 4.
There might be an odd one that asks you to do all 4. Usually we just work with ratios. Okay? But you've got to be comfortable going between all of them. All right. So now, let's look at this. For the above example, I want to write the ratio in 2 different ways. One way is called part to part. The other way is called part to whole. I'm guessing you guys can figure this out without me even describing it. If I had this ratio of 7 to 30, let's just go in yellow here. Do you think that is something that's called part to part, or do you think that's called part to whole? 7 versus 30. What do you think that would be? part to whole. 30 is the whole class, 7 is a part of it. So that 7 compared to 30 is what we call part to whole. This is our McMahon students, right? And this is all of the kids. All of kids, the kids. This is our McMahon. Right? So McMahon versus all. Okay. If I wanted to do a part to a part, let's do that in purple. Purple here. What do you think that would look like in this scenario? So if 7 went to Albert McMahon, that's one part. Right? So this is our McMahon. McMahon. What would our other part be? What do you think that number would be? It would be 23. Right? So if 7 went to McMahon, the others, there's 23 of them, and they went somewhere else. Right? All the other feeder schools. These are the others. All right? So what you're talking about compared to everybody, that's the whole. What you're talking about compared to not the total, but everybody else, that's the other. The part to part. Okay. So now, we are not going to create the 4 different versions, but with these ones, the question is, can you, if you wanted to, based off the information given right here in these ratios, can you write a fraction? Can you write a percent? Can you write it in words? So we already got it in both cases. We got the ratio notation done. Okay, so the part to part and versus part to fraction, can both of them be written as a fraction? One of them can't be. Which one can't be written as a fraction?
The top one.
The top one. Because remember, a fraction needs a total. It needs the whole. So this one can be written as a fraction. This one cannot. Right? Because you don't have the total in this ratio. Right? So if we can't write it as a fraction, then automatically we can't do the percentage. And because the fraction can easily get turned into a percent. Now, can we still use words in either scenario? Yeah, so we can still use the words, right? So you just need to be careful. If I ask you to convert, some things you can do, some things you can't, just depending on what numbers you have, right? So we're not going to do all the notes here. We're going to do some of them, right? So this one's I usually have only 2 pages for notes. This one's 3 pages long, so we'll jump around. We'll do some of it, and we'll do some of the next day as well. Let's see. Okay. Let's do this one. Actually, let's do example 2, then we'll jump over to the table. Okay. So suppose we want to write a ratio of oranges to apples. And we have 3 oranges and we have 5 apples. What do we write down?
How do we know we have 3 and 5?
I'm making it up.
Okay.
All right? I should have had this up. I made this probably when my kids at home were bugging me. So is our answer as a ratio 3:5 or 5:3? What do you think?
3.
One of them is correct and the other one isn't.
Because that's how it's written.
Yeah. So 3:5, because that's the order that it was given to you. So that's why it is not necessary to actually put the words in the ratios. because that's the order it was given to you. Right? It was given oranges, then apples. So that's what we expect these numbers to be going around. If you wrote down 5:3, I would think that it'd be 5 oranges and 3 apples, which is incorrect. Right? So that's why we can get away without it, having the words there. Okay. So let's put this to work in the following scenario. Okay, we have a recipe for some fruit punch, right? And it says it calls for 3 cans of frozen orange juice. Did you guys grow up with those frozen orange juice glasses? I grew up with those. Like the stuff you get in the little cans and you add water to it, right? So like the Minute Maid stuff. Okay, so here's the recipe to make the punch. You have 3 cans of frozen orange juice concentrate. Then you put in 2 cans of raspberry juice. And you put in 1 can of lime. And the instructions say for every can of juice that you put in, you need to add 3 cans of water. Right? Based off of this recipe, we can ask you a lot of information. So it's good to organize all this information. Right? So based off the paragraph here, we're going to organize all the data into this table so we can kind of ask you a whole bunch of questions. So how much orange juice concentrate do we use in this recipe? 3. So we're going to put a 3 here. Let's do an orange. So if we have 3 cans of orange juice concentrate, how many cans of water would we need to use for that? Not 6. Not 3. 9. For every can, we need 3 cans of water. So this would be 3 cans of orange juice times 3 cans of water, 9. Right? So next up, we have our raspberry. And we need 2 cans of raspberry. How much water do we need for that? 6, right? Yeah. 2 times 3, 6 cans of water. And it says we have 1 can of lime. How much water do we need? 3. 1 times 3 is 3. So now we get our totals. So how much juice concentrate did we use altogether? 6. 3 plus 2 plus 1 gives us 6 right here. How much water did we put in altogether? 18. 9 plus 6 plus 3 gives us 18. Altogether, how much fluid do we have? Sorry, 24. Yeah, 6 plus 18, 24. Okay, so let's put this together. So, what is the ratio of orange juice to lime juice? Concentrate, right? So 3 for orange juice, yeah. Compared to what? 9? 1. Concentrate to concentrate, lime is 1, right? 3 to 1. Not 1 to 3, 3 to 1. That's the order the information was given to us. Right? Now, with this, if it asks us to write it in a different notation, can we write this as a fraction? No, because we don't have a total in this ratio. So the only thing, we can't do fraction, we can't do percents, we could do words. Right? So in words, doesn't matter which way you do it, for every 1 can of lime, we need to add 3 cans of orange. Right? That's it. Right? So you got to know which ones you can do, which ones you cannot. Okay. Next one, we want a ratio of lime to orange to raspberry, comparing all those together. Right? What's our first number? 1. What's our second number? 3. Yep. And 2. Okay. Ratio of water to juice. What's our first number?
3.
No.
3.
It wouldn't be 3. How much water do we use? 18. We used 18 water. How much juice concentrate do we use? 6. 18 to 6. All right. How many cans of punch does this recipe make? 24. Altogether, we have 6 cans of juice, 18 cans of water. Altogether, we have 24 cans of water. Oh, sorry, of punch. 24 cans. Okay. Okay. Let's do this next one. I might give you guys an earlier break. We'll see how this goes. Okay. Write the ratio of orange, raspberry, lime to total punch. And we'll do this one together. Second part. Right? So give you a couple of seconds head start. Do the 4 things actually. So it's 4 things they ask you to compare. So you want 4 numbers. All right, so we're gonna have dot, 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 dot. You're gonna come up with the 4 numbers. Okay. What's your first number? 3, thank you. Second number, that's orange. Raspberry would be 2, that's correct. Next one, 24. Okay, so now the next one is ratio as a fraction, as a decimal, as a percent. When we do those other ones, we can only talk about one thing at a time. So let's just pick a fruit to talk about. What do you want to talk about? Oranges, lime, raspberry, doesn't matter which one you pick.
Raspberry. Raspberry. Raspberry.
I hear raspberry, I hear orange. Let's just do a combo.
Raspberry.
Raise your hands if you want to do raspberry. 2, 3, 4. Who wants to do orange? Raspberry has it. All right. So let's do raspberry. So raspberry. We got 2 raspberries. Over how much? 24. Okay, 2 over 24.
So if
All right.
we were to do an assignment and it was all those numbers, we just pick one?
I'd probably say which one to do the ratio for, right? Technically, you can do it for each one, but that's just a lot of work. Right, so what would that be as a decimal? 0.09 or something, I'm guessing?
Yeah, 0.0.
2 divided by 24, oh, 0.08. Right, so that's our decimal. 0.08. What is that as a percent? 8%. So 8% of the whole thing is raspberry. Okay, that's it. Okay, now.
You said you.
I'm only going to do one, right? I think you guys got this. I don't think we need to do this whole bunch of times. All right. Let's. The other thing I want to talk about, I think I'll stop after doing this next question with you guys, is let's just change this question here. I'm going to change this question here. All right. We did all this with numbers. We can do it with pictures as well. Instead of doing numbers, we can do pictures. Right? So let's do a different scenario than what's written here. I'm going to sort of base it off here. So, for example, if I wanted to do ratios of males to females in this class, we'd have to figure out how many males there are, how many females are. Let's count. All right, males. All right, we got 1, 2, 3, 4, 5 present today. Females, 1, 2, 3, 4, 5, 6, 7, 8, 9 present. So 5 to 9. Now that's as a ratio, but we can also do it as symbols, right? So if you want to do symbols, like maybe do stick men like this for males. I don't know if this is the best. My drawing isn't the best. Right? So we're going to do 5 of these. Then we still use our ratio symbol. Then we draw a symbol for female. And if I knew what the gender symbol looked like, I could do that. Or maybe I'll just draw the stereotypical dressed version of it, and we'll draw 9 of these. Right? So we're not limited to working with just numbers. 4, 5. So that is our ratio to male to female in our class, right? Right, lots of times when the politicians, statisticians, they show information with symbols, it's easier to communicate with the general public what the relationship and what they're talking about. All right. Okay, and I think I'm gonna stop early